Today we'll going to go through the topic of the permutation and combination. So we all know, like in the NCRT and also the RS Agarwal for the class 10th, the permutation and combination chapter is very important. Okay, so we can see like these two. The what I'm trying to say, this is permutation, this combination. So both will going to take care of for this. Okay, for the first we'll go through with the permutation, and second we'll go with the combination. So both are the topics is very important. So one by one we'll look into this and we'll go through that. So at very first, what is permutation and what is combination? Okay. So as I have written the definition of this one, the permutation relates to act of arranging. See, both will work for the arrangement. Okay. Like if we have a sets, just take example, we have a sets of data or anything you can say, the individual person, anything, and we need to, you can relate, it's a set. Okay. So if you want to choose it, like both the permutation as well as combination, both will work on the sets. So either we need to choose it or rearrange it. So when we are going to do something, apply some operation on the set, then permutation and combination will take care of, will come into the picture. So now at very first, so then what is the difference? So for difference also we'll look into later. But first of all, what is permutation? So the permutation is, relates to act of arrangement of all the members and set into some sequence or order. And combination is unlike, like it doesn't, like where the order doesn't matter. Like we are selecting from the collections, but yeah, where the orders we don't matter. So as I wrote here, you can see the permutation. So the order matters in the permutation. The arrangement selecting. Just example, we have example like if we want to choose the president, vice president, secretary from the group of people. Like whenever the group of people are there, like we have a group of people 1 2 3, and like one by one we'll choose. So order matters, right? Like we'll first select the president, then we'll select the vice president, and again we'll select the secretary. So it's the order matter, like 1 2 3 order, right? So in that case we will go with the permutation. Okay, and if there, like we just have to pick all, or we just have to take care of, like sets, then at that moment we don't have to go with permutation because their order is not there, right? We just have to take the group of people or group of sets. So at that time only combination will work, not the permutation. So this is what I wrote here. See, where the order doesn't matter, the arrangement of the select item is not important. Like just example, we have 3 books from the library to read. The order in which you select them doesn't affect. You just either you take the first or second anytime, or just take the all the 3 books. So order doesn't matter. So wherever the order is not a priority, order is not a priority, right? So at that time we will give for the combination. And here what is, like it is where order is priority, correct? So these two we'll see the permutation and combination. Now what we'll do is we'll erase some of the, and now what we'll see is for the permutation, right? For permutation we denotes permutation as a P, and here it will be a NPR. We denote the permutation of the sets as where N is a total number of commodity, like total number of, you can say the commodity or the number which is given for the permutation, like group, like we have a here president, vice president, and secretary. So it's a group of people. How many are? 3. So it will be a N denotes the total number of group, like total number of people is there, and R is like what we are choosing it from there. So R is like what we choose from the set. So and we denote like NPR, like this. Same for combination also, we select as NCR, where N is the total number of commodity or total number of people, and R what we choose from there. But here the order is not a priority. Okay, so now we'll check with the few formulas. Okay, now we have few formulas for the permutation and combination. So this is what I was trying to say. See, NPR we denote for permutation, and this we call this denotation, right? And this exclamatory marks we write it as a factorial. Okay, like FACTORIAL, we call as a n factorial. So what is the formula now? Like NPR will have NPR is n factorial by n minus r factorial. Okay, so what is n factorial? Like if you see n can be any number. Okay, so if you can see anywhere it is written like 5 factorial. 5 factorial is how much? Like we can reverse to till 5. We'll start from 5 and reach to the 1. How, what I'm trying to say is 5 into 4 into 3 into 2 into 1. So this is what it is called a 5 factorial. What is 4 factorial? 4 factorial 4 into 3 into 2 into 1. This is called a 4 factorial. What is 3 factorial? 3 factorial is 3 into 2 into 1. So it will go like the descending order, like from big to small until the last. So like 3 will start whatever the number you are giving, like n factorial, right? So it will start from n to 1, correct? So the same, just take example, if you given as a 6 factorial, so what will write? Like 6 into 5 factorial you can write, because 5 from 5 also we need to go to 1, right? So we can break this like 6 factorial, we can write like 6 into 5 factorial. If you can write as 5 factorial, what we can write is 5 cross 4 factorial, because again we need to say, we can see like 4 into 3 into 2 into 1. So we can write, we can stop it here itself by writing the 4 factorial. So 5 into 4 factorial, if we write 5 into 4 into 3 factorial, 5 into 4 into 3 into 2 factorial. So we don't, if we don't write, we don't have to go to 1. If the problem is like that, we'll see the problem also, how it will be taking care of it. Okay, now we'll check for the NCR. So now for the combination, we can see the formula of this one, right? NCR. What we'll write is, we'll first delete this one, the another one. Yeah, now we'll see with the combination. Combination, we have a NCR. How we'll write? NCR is equal to n factorial by r factorial, and it should be like n minus r factorial. This is the formula for combination. And in the last slides, which we saw, like the permutation will come where the order is a priority, and combination will come where the order is not a priority. This is how we'll differentiate and try to solve our problem. So we'll see the problems also. Going forward, we have like few sets of problem where we can see what is the where we can use the permutation and where we can use the combination. Okay, now we'll see some of the differences, like where we use the permutation, where we use the combination. So just a small example, through that we can check like how it work and all. So you can see like we have a difference of what? Difference of permutation and combination. Okay, so where we use the permutation, where we use the combination. So just take example, if we have a 5 friends, okay, and we want to choose 3 of them to go to movie. So here you are not giving the priority of order, correct? Like in which order you select your friend, you just tell your friend, okay, I just choose 3 friends, you will go for a movie. So here we always use the combination. Okay, now as we gave some we saw some example, right? Like if you want to choose a president, a vice president, a secretary from the same 5 friends, so order does matter, like in which order you select, like you select the president, then vice president, secretary. So in that case we use a permutation, so it should be denoted as P, and here it will be a C, correct? So P is for permutation and C is for the combination. So in summary, like the same thing I'm trying to say is, a permutation is used where the order matters, while the combination are used where order doesn't matter. So what we are saying, like wherever the P is there, in that order matters, and where C, order doesn't matter. Okay, so this is what a basic concept you can say, if once for the permutation and the combination. Now we will see for a few examples. Okay, we will solve some of the numericals to check like how to solve the problem for permutation and the combination. So the first problem, okay, it's very simple, it's very small. Like we here what we can do, what we need to find is, find the number of permutation and combination for n is equal to 2f and r is equal to 2. Okay, So we all know, right? We have a formula at very first. First formula is for permutation, okay? Permutation. Here I will go for the combination. So permutation formula is n p r. So formula is n factorial by n minus r factorial. Correct? N we have given as 2, r is given as n is given as 12, r is given as 2. So when we'll put the value here, so it is like 12 factorial by n minus r means 12 minus 2 factorial. Okay. So as you know, right, we can write 12 factorial is like 12 factorial by 12 minus 2 is equal to 10 factorial. Correct. So you know we can write 12 factorial as 12 into 11 into 10 factorial by 10 factorial. So this 10 and 10 factorial will go, and now is 12 into 11. How much it will be? It is equal to 132. So this is the value of permutation. Value comes as 132. This is the answer. Now we'll go with for the combination. Okay. So combination, we know the value, right? It is NCR. What is the value? What is the formula? N factorial by R factorial n minus R factorial. So here when we put the value, n is equal to 12 factorial by 2 factorial by 12 minus 2 factorial. Okay. So when we'll solve, is 12 factorial will keep it at is 2 factorial. 12 minus 2 is equal to 10 factorial. Okay. So what we'll do is we'll write 12 into 11 into 10 factorial divided by 2 factorial into 10 factorial. This 10 factorial, 10 factorial gone. This 2 factorial is equal to 2 only, correct? So 2 6 are 12, 11 6 are 66, correct? So the answer is 66. So we got the value of NPR and NCR both. So this is how we'll solve the problem. So it's very easy, very simple. Okay. This is wherever we need to put the formula. We just put the value here and try to get the answer. So this is how it is. Now we'll go with the another problem statement. Okay. Okay. So in this problem, it is written, it is like in how many ways, if you can see, we need to, read the question very, very carefully. We should understand it, what is trying to say. In the second question, what he is trying to say is, in how many ways a committee consisting of 5 men and 3 women can be chosen from 9 men and 12 women. Correct. So total men is 9. Total women is 12. So this is what is given. Total men we have given. So in how many ways we can able to choose? First we need to choose, right? So in how many ways you can choose 5 men from the 9 men, because total is 9, right? So choose 5 men from 9 men. So it should be 9C5. Correct. We are choosing because here order is not at all priority. We just need to choose it. So the formula is 9C5. Okay. So we know, right? For the combination, it is NCR. N is 9, R is 5. N is a total number. So total number is given as a 9. Correct, for men. So we are choosing the men, 5 men from the 9 men. Okay, so how it will go is like it will 9 factorial divided by 5 factorial. 9 minus 5, 4 factorial. If we'll solve this, the value will come as 126. Okay, now again choose 3 women from 12 women. How will choose? Again 12C3. So it should be like 12 factorial by 3 factorial, 12 minus 3 factorial. Okay. So if we'll solve it, we'll get the 220. So now see, we got 5 men, we got 5 this one, we got women from, so we chose, like in how many ways you can choose a 5 men from 9 men and 3 women from 12. Now we got now what we'll do is we need to find a total number of ways. So total number of ways is We need to multiply it because both we need to take consider, right? We are not considering only one. So we need to multiply always. So whenever you want to take the total number of ways, it should be 126 into 220. So how much it will be? 2770 ways. So how many ways the committee can be consist? From the 5 main, we choose the 5 main from in this way and this much. And we need to multiply it and we get the value of 2770 ways. We can form a committee which consists of 5 men and 3 women. So this is how we will try to solve the numerical. Okay. Now we'll go with the another problem. Then you will understand more like how the permutation combination come into the picture. Okay. The another problem is like in how many ways the letters can be arranged so that all the vowels comes together. The word is impossible. The word here written as a impossible. We know the vowel, right? They are written like vowels can be come together. What are the vowels first? Vowels is either A, E, I, O, U. These are the only vowels, okay? So what is telling is in how many ways can the letter be arranged so that all the vowels come together. In this impossible, how many vowels we have? We have I as a vowel, okay? O as a vowel, then I came, then again E came, correct? We have a 4 vowels in this impossible word. So how we will solve this one? So what it is saying like in how many ways can the letter be arranged so that all the vowels come together. So we will consider this I, O, I, E. These are the 4 vowels are considered in the impossible. So we'll denote as a super keyword. Okay. We can write anything like super keyword as a just take example V. Okay. Or we can just keep it like this only for the understandable purpose. So how we will write this? We can write the same impossible keyword like this, right? I, O, I, E, then M, P, S, S, B, and L. Correct? So it is telling me like keep all the vowels always together. Okay. See, comes together. So we will consider this one packet where all the vowels are there as a one. Okay. Then this is second. This is a third. This is fourth. This is fifth. This is sixth. This is seventh. So how many ways we can arrange this word? 7 factorial. Okay, factorial 7 factor. In how many ways we can rearrange this word? So this is one. We always keep the vowels in the as a one packet. Okay. So we created one packet where we kept all the vowels together. So we'll not look now. We'll tackle this one later. But first, just take like in how many ways in how many ways you can rearrange this word. So we have one packet as 1, then 2, 3, 4, 5, 6, 7. I know this is getting repetition, but we don't have to look now. We'll take this consideration later also. I'll tell you what. So now we have a 7 letters. Okay. So factorial 7 we can rearrange it. Okay. Now after that we need to divide it. Divide by there are 2 letters which are repetition. Okay. So we need to give 2 factorial. So this is how we can rearrange it. Now this I, O, I, E can rearrange, right? This also we can keep I here, O here, then I, E, O, then I, E, O. We can rearrange this in 4 factorial ways, right? So we need to multiply as a 4 factorial, correct? Now this also have a repetition. See, I, O, I, E. So I is getting repetition. Again, we need to divide by 2 factorial because these 2 letters are getting repeated. So this is how the problem will be get solved. So this is our last solution, 7 factorial by 2 factorial into 4 factorial by 2 factorial. So when we will solve it, we have a 7 factorial by 2 factorial into 4 into 3 into 2 factorial. Okay. Here also 2 factorial, 2 factorial gone. This is 12 and here also we can write, right? 7 into 6 into 5 into 4 into 3 into 2. Here we have 4 into 3 and we can write like 2. 2 gone, 4 3 are 12 and this multiplication answer. So what will the value will get? We will get the value as 30240 ways. When you solve this complete thing, You will get the value as 30240 ways we can arrange this impossible keyword where all the vowels will always be together. So this is how we'll solve the problem. Okay. Now just come with the we have one more problem, so we need to check. Another problem is like same kind what we have just solved it, right? How it is. So in how many ways the four girls, we have a four girls given. See here, four girls, and we need to create a team. Okay, four girls and seven boys out of 10 girls and 12 boys. So what we'll do is number of ways to choose girls first. It should be how much? 10 C4, correct? Ways to choose boys. How much it will be? 12 C7, correct? Because we need to choose 4 girls out of 10 girls, 7 boys out of 12 boys. Now total number of ways. If we'll try total number of ways, how much it will be? 10 C4 into 12 C7. This will be our answer. When you try to solve it, you will get the value. You will get the value is around how much it will be. It will be like 166320 ways. Okay, this is how we try to solve a problem. Now just come to the last problem. Okay, for the today's video. So going forward with this video, I would like to request all the students out there who are liking my video and try to understand how the basic concept of this. Please like and subscribe if you really like my video and all. Okay, then chalo, we'll solve this last question for today. So we have a consonants, okay, and we have a vowels. Like it is telling how many words can be formed from the 3 vowels and the 6 consonants taken from 5 vowels and 8 consonants, correct? So just take example. We will have a, how will we solve it? Okay, we need to choose 3 vowels from 5 vowels, correct? So how it will be? 5 C3. Done. We chose the vowels from the 5 vowels. Now we need to choose 6 consonants from 10 consonants. How it will be? 10 C6. Now come. Now we have one more trick here. See, it is telling me how many words can be formed. Now when we chose 3 vowel and consonants, we form a word. Just take example with the 3 vowels and 6 consonants, we form a word with the 9 letters. Correct? Now we can rearrange also, right? This 9 letters as well. So when we created the letter, when we created a word got created from the 9 letters. So these 9 letters can rearrange, correct? In how many ways these 9 letters can rearrange? 9 factorial. In 9 factorial ways we can rearrange these 9 letters also. So how many total number of ways when we will write? Total number of ways will be 5C3 into 10C6 into now 9 factorial. This is our solution. So this is very important. Okay, in this question we saw like when we chose the letters and consonants, now we need to create a word from there, right? We need to create a word from the vowels and consonants, correct? So when this logic will come, that also we need to take care of it. Okay, the nine letters can form one word in this question. So 9 letters can also rearrange among themselves, right? So it can rearrange how many ways? 9 factorial. So the complete answer will be 5C3 into 10C6. This is for the vowel, this is for the consonant, and this is for the complete whole letter, whole word. Means vowel plus consonant. This is how we'll solve. Okay. Chalo, for today's we are going to finish this video. Okay, thank you so much. Take care. Bye bye.